Thank you all for coming out tonight. It's really my pleasure to welcome you to tonight's keynote with Andreas M. Antonopoulos. My name is David Moskowitz. I am the co-organizer of the Bitcoin Singapore Meetup Group and also director of membership for Access, the Singapore Blockchain and Cryptocurrency Association. So Access is very happy to be sponsoring tonight's event, along with the help of the folks from the Bitcoin Meetup, the Ethereum Singapore Meetup, which is a self-organized community led by Ethereum startups and co-founders to promote Ethereum as a solution. The refreshments are thanks to the sponsorship of Access corporate members, Cost.io, CoinHako, and Sage FinTech. So just a very quick thank you to these guys. Very generous of them. So Cost.io is a crypto one-stop solution portal bringing cryptocurrencies to the masses. CoinHako is the leading wallet service in Singapore and Malaysia. Buy and sell your Bitcoin in minutes. Hopefully buy more than sell. Keep that price going up. Just kidding. Sage FinTech is founded by senior Asian bankers and banking technologists whose mission is to serve the unbanked population by empowering the Asian microfinance industry with innovative banking quality solutions like Sugima.id, a Sharia-compliant microfinance platform. So the nonprofit association Access promotes and protects the use of and development of digital currencies and blockchain technologies. We have three core activities: advocacy, helping to promote our members' interests; engagement with the community and the government to create a common voice for our members; and education. We offer introductory classes and help to educate the public about the transformational power of blockchain and cryptocurrencies. So you can sign up to become a member at http:// can't believe I still say that, access.sg.org, or speak with one of our board members during the networking session. We're also running a special campaign in honor of Andreas this week. It's going to be $30 off the individual membership or corporate membership, and you can just use community as the promo code. We'd also like to thank SMU. SMU has been a huge help with putting on this event tonight, and SKBI for providing the venue and all their administrative support. We couldn't have done it without them. The Sim Kee Boon Institute for Financial Economics is the premier Asian institute for research and training in financial economics. It is a think tank in SMU that spearheads and excels in cutting-edge research in finance and financial markets, which have strategic and practical relevance to the Singaporean regional economies. Supported by faculty and in collaboration and partnership with industry experts, relevant government bodies, and other world-renowned research agencies, the Institute conducts fundamental and applied research which is driven by industry and societal needs in Singapore and the region. Besides research, SKBI also actively engages in training and consultancy, executive education and research, dissemination through organizing courses, seminars, and conferences. And I think some of you have been to the earlier cryptocurrency conferences starting in 2014, 2015. Their purpose-oriented activities are designed to serve as enablers in bridging the gap between theory and practice and to act as accelerators in helping to shape financial policies and regulations, which are especially important given the uncertainty in the global markets. So for many of us, Andreas was one of the most important voices for helping us understand Bitcoin. He's been a voice for the community, speaking at numerous community events, just like tonight, as well as helping various governments understand the potential of the technology. He's also been making the case for innovation rather than regulation. His book, Mastering Bitcoin, is considered the best technical guide to Bitcoin, and The Internet of Money, a book about why Bitcoin matters, is also a must-read. So everyone, if you could please give a super hot Singapore-style welcome to Andreas Antonopoulos.
Wow. Hello, everyone. Can you hear me in the back there? Yes. Yeah, okay, great. This is my second time in Singapore. I was here 10 years ago approximately, which means that in the intervening time, you tore down half the city and rebuilt it just to make fun of me, so I can't recognize any of the landmarks. Singapore style means rapid change, and this is truly an amazing place to visit. I'm really glad to be here. Thank you all for coming tonight. I'd like to thank the sponsors, Access, who made this possible. It took quite a bit of planning because it was on quite short notice. This is part of a Southeast Asia tour I'm doing. My next stop is Mumbai, so one quick flight, and we can do all of this all over again 4 days from now. So how many people here are new to blockchains, digital currencies, Bitcoin, Ethereum, et cetera? OK, great. How many of you have done a transaction in any cryptocurrency whatsoever? OK. And how many of you have or hold cryptocurrencies right now? OK. How many of you are willing to give some of those cryptocurrencies to the people who are new in this room? Quickly, pay attention. If you are new to this space, if you've never done a Bitcoin transaction or an Ether transaction, if you've never seen how cryptocurrencies work, come see me or any of one of the people who just raised their hands after the talk. I will be delighted to give you 1 or 2 milli-Bitcoins. No joke, in the end of 2012, I was giving out 1 or 2 Bitcoins to people I met at meetups like this. It's best not to look at the cost basis. It depresses me if I think about it too much. But I will be very happy to give you some currency, mostly so that you can experience what a transaction looks like. All right. So let's get started. The title of this talk is Hardware, Software, Trustware. How many of you have been paying attention to this whole business about a fork? Has anybody heard of a fork? There is a culture gap that is being expressed in this fork. And most people look at this and they see the obvious culture gap. Most of the mining happens in China. Most of the miners are Chinese. A lot of the development happens in Western nations. A lot of the developers are from Western nations. And at a first glance, it looks like the culture gap is some kind of East-West thing. It's not. In fact, I think a much better framework for thinking about this is that the culture gap at the center of the debate we're having today is a culture gap between people who build hardware and people who build software. And those cultures have been diverging since the 1950s. If you're involved in computer science, if you do hardware or software for a living, you know what I'm talking about. Software goes way back, but not as far back as hardware, because the very first software was hardware. And if you wanted to use a computer, it ran one program. Some of the first computers run very specific programs. Probably one of the earliest examples is the Enigma cracking machine at Bletchley Park, built by Alan Turing to crack the German cryptography during World War II. It did not have software per se. It had inputs. You could input the message, and it would try to figure out the key. But it only ran one program, and you could barely really call it a computer. It was an electromechanical device with a bit of electronics, very primitive. Software started happening in the 60s. And software represented a giant leap forward, because until then, if you wanted to reprogram a computer, you had to change its wiring. Or you had to flip a lot of switches, like a lot of switches, like 10,000 switches in a big bank of switches. And if you got one of them wrong, that was a bit of a problem. Programming in binary, not fun. And out of this, gradually, we started having these two cultures emerge. The culture of people who build hardware and the culture of people who build software. And the fundamental difference has to do with the life cycle of development. And that persists to this day. When you build a hardware device, Your life cycle is measured in months, if not years, 18 to 24 months. You design a chip to do something. You make some architecture decisions. These decisions will arrive at the marketplace 2 years from now, and if you got them wrong, you start again. If you make a mistake in hardware, things happen, and you can't issue a patch. If you ship a phone that has a nasty tendency of blowing up, there is no software patch that you can issue that will fix the battery issues. It's out there, in people's pockets, getting hot. The culture that comes out of that is a very conservative culture. The planning timelines for building hardware are very long, and they require absolute precision. If you make a mistake, you don't just change a line, recompile, try again, issue a patch. You recall $1 billion worth of silicon and turn them into scrap because you made a mistake, a nanometer scale mistake. And at first, software was like that. Because if you programmed, say in Fortran, on a punch card, and you had 6 minutes of compute time a day, and you spent 20 hours writing your software and punching it into cards, and then you submitted it to the mainframe, and during your 6 minutes, the mainframe would go, bzzzt, error. Now you have to go back, spend a day figuring out why, fixing it, punching it back into cards, and putting it back on the mainframe during your next 6-minute window. That's how programming started. And if you were a programmer in those days, the attitude was, well, thank God I don't have to flip 1,000 switches to do this. This is so much faster. It only takes 48 hours to do one life cycle. And gradually, this gap started shrinking and shrinking and shrinking. If you're a really, really crap programmer, you don't even plan, design, or think much about your software. You just put some shit together, hit run, see what happens. Fix it, run, see what happens. Fix it, run, see what happens. You iterate really, really fast. The really great programmers are not that sloppy. They put some thought into every line they change. But all of us have moments when we start hacking. That's where the phrase hacking comes from Berkeley in the 1970s, where that's how they fixed software. You just hack at it until it works. But that encourages a mentality where your worst mistake lasts 2 minutes, and no one gets to see it because you don't ship that. That's the beginning of a drift apart of two cultures. In hardware, your mistakes are immortalized on silicon, and they might start fires. In software, your mistakes disappear somewhere in a Git log. Nobody really has to look back at the previous commits and see all of the horrible code you wrote. Right? We all do that. If you've done software programming, that's how most of us program. That has some very interesting implications for the current debate, because there's another fundamental and really important difference in the culture between hardware and software. Hardware is all about ship date. You work 2 years for that day when it ships. And once it ships, it's out of your hands. You made the right design trade-offs, great. You made the wrong design trade-offs, you're going to be 5 years behind your competitors until you figure it out again. But that ship date is the last date. And once it's out there, it's out of your hands. Look recently at the perennial battle between AMD and Intel. How many of you are familiar with chip architecture in AMD and Intel? About 2 years ago, not too many, so I'll make it simple. 2 years ago, AMD and Intel started working on their latest generation chips. And having a 5-year horizon, they had to make some bets, some trade-offs, some design decisions. AMD made the bet that most systems that ship have a graphical processing unit, and that for advanced mathematical operations, matrix manipulation, floating point arithmetic, etc., you would have a development environment that would take that, optimize it in OpenGL, and ship it to the graphics card for processing, because it's 1,000 times faster for that kind of work. So why would you do that on a general purpose CPU? It didn't seem sensible. So they decided, let's put 64 cores on a chip, but only give them 4 or 8 floating point arithmetic units. Intel said, the software is not going to get that good. It's not going to specialize these instructions. Let's put just 8 cores on a chip, but give every one of them a floating point arithmetic unit. 2 simple trade-offs, right? 2 decisions. Is the industry going this way, or is it going that way? Are we going to be able to leverage this new technology or not? Will the software catch up with what we're trying to do? Will the architectures of the future look more like this or like this? Agonizing over that choice, they get a ship date in mind, and they ship. Intel got it right. AMD got it wrong. Intel dominated the desktop and server environment for this cycle, right? Now, AMD gets to try again 4 years later, 3 or 4 years later. That simple trade-off changed the fortunes of that company and the direction of an industry. We see this in other examples. Let's go for bigger hardware. I'm a fan of aviation. I'm a private pilot. I love that stuff. Boeing, Airbus. 5 years or so ago, they made a very important bet. Airbus said it's mostly going to be about hub and spoke connections. You're going to have big hub airports, and they're going to run hundreds or thousands of passengers on single routes. So what we need to build is a double-decker aircraft that can seat more people than ever before. And Boeing said, no, it's going to be mostly regional point-to-point. And if we take an aircraft and allow it to extend its range to 12,000 nautical miles, then that choice is the better choice. And they built the Dreamliner. Boeing was right. Airbus was wrong. Boeing shipped 100 times more Dreamliners than Airbus. We'll never catch up quite. So now they get to try that again. But it's going to be a 5-year life cycle. If there's a bug in your software, even in this environment, you can fix it in a matter of hours, ship a new release, done. So one important difference is this idea of ship date. Once you put it out there, you're locked in for a couple of years. And that makes you have a much more conservative attitude. But it has a good side, because you will only encounter one of those ship dates a couple of times a decade, 3 times, 4 times a decade. That's it. With software, however, something else happens. Your ship date is not the end of your problems. It is the beginning of your problems. Because once you ship, maintenance starts. And very quickly, it became apparent in the software industry that software behaves a bit like perishable produce. It's got 3 days of shelf life, after which, if you haven't done maintenance, it starts rotting on you, right? Software gradually degrades, especially today's software, which is open source software in a very dynamic environment with lots of dependencies to third-party libraries. Everything is moving. SSL changes something, we find a new bug, new release. The tolerances of the network change, new release. Berkeley DB doesn't behave the way you expected, new release. And so software is like a never-ending relationship, which you're trapped in. Like, there is no ship date. It's continuous shipping. It's continuous maintenance. There is no, and now we're done. There's only, and now our troubles begin. This divergence has created a massive culture difference between the culture of miners and the culture of software developers. It is at the root of the current discussion we're having. From the perspective of someone building hardware, of course, you're not going to ship a new chip architecture to fix the problem. Just juice up the clock speed. This architecture still has plenty to go, right? It's got room to grow. Change a parameter, for God's sake. Juice up the clock speed, and we can keep the current architecture and just ship it. From a software developer's perspective, if you're looking at the bigger space, it's much better to change the architecture now before you have a lot of technical debt and software crud and accumulated UTXO and enormous blockchain sizes on your data store that you have to keep forever. And of course, you're going to be maintaining this shit either way. Might as well do an architecture change. This is the fundamental culture difference between the mining community and the software development community in Bitcoin, and not just Bitcoin. Bitcoin is just the one that has the strongest, biggest, most vocal mining community. But that's not the end. That's just the beginning. Because without even noticing, we now have a completely new category which is going to create a completely new culture. And that is Trustware. What is Trustware? Trustware is this weird emergent phenomenon that happens when you combine consensus rules that are running and instantiated in software with the backing of hardware deployed on a global network with a diverse set of participants. All of the headaches of hardware, all of the headaches of software, and some new ones. Now, when you ship is really important, because if you're making a consensus rule change, you have to coordinate an entire global network. But the ship date is no longer the end of your problems. It's just the beginning of their problems, because now you have to maintain it forever. And every mistake you make gets baked into the blockchain and has to be carried with you in the consensus rules forever. In Bitcoin, there are no bugs. There are only consensus rules created through tradition. So how many people here are software developers who've worked in Bitcoin at all? All right. You probably know about this one. It's a classic. So when you write a multi-signature script, and the code gets to the part where it says op check multisig verify, the code has to go and pop as many keys off the stack as you've defined as the last parameter, n, right? And then inspect the signatures, which should be m of n, and do something. Turns out, op check multisig verify pops one extra value. That's a bit of a problem, because if you do a multisig of 3 keys and it pops 4 things, there aren't 4 things on the stack. And if there aren't 4 things on the stack, you get a stack error, and your script crashes, and your money is no longer spendable. Now, when that bug happened, because it did happen accidentally, back in probably 2011, it wasn't fixed before. Some people put spendable Bitcoin and redeemed it on the script, on the blockchain. And to do that, what they did was they put what's called a null value, a dummy value. So they go, OK, you want to pop 4 things off the stack, 3 of which have to be keys, and 1 which is going to get ignored? Here's blah, key, key, key. And so you pop blah, key, 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 throw away the blah, keep the 3 keys. It works. Done. But now, that script has to be valid forever, because every node in Bitcoin validates everything forever. Oops. Now, developers are writing new versions of this software. Multisig is now part of a pay-to-script hash formula. Guess what? It still pops an extra value. And so I write in my book, there's a big old notice, and it says, you will see an extra value in all the redeem scripts. That's because there's a bug. That bug cannot be fixed. It's with us forever. Why can it not be fixed? Because the fix is worse than the problem. I mean, sure, you could fix it. You could just put a thing in the code that says, from now on, just pop 3. And now everybody knows it, and they write redeem scripts that just pop 3. Fine. No problem. But now you have a piece of code in your blockchain, what is effectively a soft fork that says, before block X, pop 4, after block X, pop 3, if you see this script. So that all of the scripts that came before are valid, and all of the scripts that will come next are also valid, but don't need that dummy value. What you've done is you've moved the CRUD from your scripts into your code. And now these 2, 3 lines of code need to be maintained forever. What if there's a bug? If you write 3 lines of code, on average, one of them is going to be wrong. So for every line of code you add to the consensus rules, you've got to make sure you don't add a bug. How do you coordinate an international network so that everybody makes sure they change the rules at the same time and you don't accidentally invalidate transactions? This is the essence of Trustware. The essence of Trustware is we are now writing software that gets backed by hardware, deployed on a network, and establishes a set of global consensus rules, which if you make a mistake on these consensus rules and go out of consensus, you can lose millions. You can get cheated out of transactions. You can be suffering replay attacks or malleation attacks or all kinds of other attacks. This is not a game. This is a new software frontier, only it's not software. It's Trustware. And Trustware is way more complicated than software or hardware or software and hardware put together, because there's also a global network component that's controlled by independent actors. Why on earth would we do all this? I mean, it doesn't sound like a fun development exercise. Why are we creating this thing that will have its own culture, Trustware developers, consensus experts, that requires its own deep understanding and analysis and review? Why are we doing this? Because it gives us something amazing. It gives us a decentralized platform of trust that is neutral and not controlled by anyone. And that's worth it. But it's bloody painful. And so this is where we are today. Within this network, especially in the case of Bitcoin, we are now seeing a direct conflict. It's not a violent conflict. It's simply a conflict of ideas. It's a disagreement about the future of the network. It's a disagreement about the future of the currency and the future of the consensus rules. I have to assume good faith. I think both parties see the way forward as the best way forward for Bitcoin. But in technology, it's not just a matter of opinion. There is truth. Truth means something. There are correct opinions and incorrect opinions. There are opinions that match the facts and ones that don't. It's not a system of belief. It's a system of science. Unfortunately, most of the conversation that's happening really looks like a system of belief, or more likely, a competition of soccer. So on the one hand, you have diehard fans of FC Barcelona, and on the other hand, diehard fans of Manchester United. There is no right or wrong. There is no correct answer. There's only my team and your team. And your team is wearing the wrong color, they look silly, and they can't play soccer. Clearly. Any intelligent person can see that. Unfortunately, that doesn't lead to any scientific conclusions, which is why we're here. So what we're seeing today is the culmination of a fundamental culture clash between people who primarily build, manage, deploy, and run hardware, and people who fundamentally build, manage, and maintain software. And that's why you'll notice there's some Chinese people on the software side and then some Westerners on the hardware side. And this is not a culture clash between East and West. It is a culture clash between hardware and software. And from within that, a new culture is now emerging. A culture of developers who are building Trustware, who are gradually seeing the nuances and incredible difficulty of building a system of consensus rules that is backed by hardware and deployed on a global network, and that is Trustware. Thank you. Why not?
Yep. There's some microphones lined up. If you guys want to ask Andreas some questions, please feel free.
Come on, don't be shy. Jump up, ask me some questions. Please stand up and stand behind the microphone so we can catch it on the audio. Don't be shy. You don't have to say your name. And we won't turn the camera to look at you. Just.
Hello. Hello.
My question is going beyond just transactional and financial, the Trustware application for political and social kind of manifestations. So what do you think it's going to take for us to see application of Trustware beyond just financial, so political and social?
That's a good question. What do I expect to see for the application of this technology to the social domain, to governance, to politics, to society beyond the financial? Time, lots of time, because this technology has a long way to go to mature. But I also think that before you see it applied in the political sphere, it has to work first in the financial sphere. One of the things that we've seen with Bitcoin, which is really astonishing but really promising, is that people don't care about passwords. People don't care about private keys. People don't care about security until they have Bitcoin on their smartphone. And suddenly, InfoSec becomes an interest. If you have money on your smartphone, like money, real money, and at first you don't think it's real money, but you hold it for a while, and then maybe it goes up in value, and then one day you look at it and you go, oh, that's real money. That's a lot of money. It wasn't that much last time I looked at it. I was in Prague in a bar having a conversation with someone, and they asked me what I do, and I said I work in Bitcoin. And they said, oh, I remember that. I mined that back in 2011 on my PC. How's it going? So I said, did you keep that PC? I'm not answering the question yet. Did you keep that PC? They said, yeah, I think I have the hard drive somewhere. And do you remember how much you mined? I said, not much, maybe 150, 200 Bitcoin. So I said, sit down. At today's price, your Bitcoin is $700 each. He said, no, it's not. So I showed him on my smartphone, and he went white. I mean, he was already white, but he went whiter, like a lot whiter. He just started like shaking. And he told his friends, I'm going home right now. I could just imagine the scene where he's like digging through hard drives. So I advised them to look for the wallet.dat. But anyway, side story, the point is, you never know when suddenly that little hobby you were doing back in 2011 becomes money. But one thing becomes very real. People start caring about security. People who never set passwords, people who set their password to password 1234. And I'm seeing a few faces in the audience here who are going, hang on, that's my password. How did you know? They start caring about security. Before you go and use this technology to vote, you have to take the security seriously. If someone can steal your vote, and you don't particularly care about your vote, you're going to lose the keys. You're not going to maintain a backup. But if that same device is holding your money, the lease to your car, your house, and your vote, primarily because of the first thing, your money, it's well backed up. It's the most secure thing you run. Maybe you're using a hardware wallet instead. You care about the security. So one of the reasons I don't think we're going to see social applications of this is because first you need to care about it. And the only way we found to care about it is to put money on it. Yes?
Yeah, Andreas, I have just come from Mumbai, and as you are aware, our country went through a complete exercise in which 86% of the currency was removed by the government and new notes were put in. Interestingly, at that time, the interest in Bitcoin has surged. On Friday, I had a meeting, I had a chance to discuss. In India, we are coming out with our own digital identity platform called Aadhaar, by which every Indian's 13 biometrics are put on a unique number, and they have a whole process of deduplication. So I had a chance to ask him on this whole issue of how would blockchain fit into this entire. So he said not right now. His opinion was that with an Aadhaar-based system where you already have identity available if you need, the blockchain would not really play a large role in that. I just wanted your perspective on that.
So for those who may not have heard the details of the question, India went through a demonetization exercise where 86% of the currency was withdrawn with 4 hours notice. And for some odd reason, interest in Bitcoin skyrocketed thereafter. So the next question was that India is now building an identity and biometric management system called HackMe.
Aadhaar. Yeah, okay.
It's not called HackMe, please.
I get the point. I get the point.
It should be called HackMe.
Okay.
Or bribe me and I'll make you whoever you want.
Okay.
I can't wait.
Okay.
I think the most important criteria for systems like that is that everyone should be registered, including the politicians who voted for it. And then I hope that the first people who get hacked are they. And then they get to see why that's a bad idea.
Okay.
The fundamental problem with systems like this is the same problem with all of the systems that we're trying to fix. It's not whether it's stored on a database or a blockchain that really is a database, but with better chances of getting VC funding. It's really about, is it centralized or decentralized? That's the question. And all of these identity systems managed by governments, are centralized in their very nature. Okay. And they are the source of inequality, injustice, misery, and corruption on a massive scale. And you can't change that.
Thank you.
Thank you. You can't change that by putting it into a different type of database. You need to address the issue of centralization. Let's go on this side. Ansel.
So just a question from the community as well. SegWit versus Bitcoin Unlimited. What's your opinion on it?
Okay. So this is the kind of really, really difficult question. But at the same time, it's fairly easy. I'm in favor of activating SegWit. I'm in favor of activating SegWit now. The reason for that, and don't applaud, form your own damn opinion. I am no more the authority you should listen to than anyone else. This is not a system of belief where I said FC Barcelona and you go, yeah! Make up your own mind. I'll tell you why I think that's true. I think SegWit should be activated now because it solves a number of different problems. It's the best tested solution that exists. I also think that I will make a disclosure. I used to think that big blocks would be better about 2 years ago. And I ran Classic and XT to evaluate them. I ran Bitcoin Unlimited too. Not because I thought that we should hard fork to those, but to evaluate the software and understand how it works. And if the choice was SegWit versus Classic, I might say, you know, a year from now, we could also do a bump through Classic. The problem with Unlimited, in my opinion, is that it doesn't change the rules. It changes or sets the rulers who then get to change the rules. And that is a very dangerous thing to do in Bitcoin, especially if it's done as a contentious hard fork. I think Bitcoin Unlimited is a completely untested system of consensus. If somebody wants to test that with 51%, it's going to be an interesting experiment. Bitcoin is going to get attacked eventually. Maybe it's better if it gets attacked sooner rather than later. If you hold Bitcoin as an investment, this will be painful. So hard forking Bitcoin with a low percentage and without very broad consensus will damage Bitcoin. We will end up with two chains that will survive, and the sum of their value will be far less than the sum of value we have in Bitcoin today. I think that's a very bad idea. Not my choice. However, here's something I can tell you. Bitcoin as a currency, as a means of exchange, the way I use it for getting paid for my job, works at $200, at $2,000, and at $20. It doesn't change for me. Bitcoin as a stable store of value, however, doesn't work with a hard fork. So it really depends on what you use it for. And there's probably a broader discussion to be had there. Let's see if we have some more questions. This side. Don.
Thank you. Sorry for monopolizing the questions in the fifth MOOC, and I'm back again.
Yes.
My questions regarding, well, actually, my first question was just answered.
Just one question.
Briefly then, how does what you just said go into the other blockchains? Ethereum Classic will stay on GPU mining. GPU mining is sort of software-ish rather than not quite hardware. In Ethereum itself, it would be then proof of stake, which is totally software. So there'll be one group. Ethereum Classic would still be two groups, but no hardware involved. Ethereum would be one group. And then just to touch on just one comment that you left in the fifth book, which I loved, that you said Lightning was Bitcoin proof of stake. I just wanted, that, how does everything sort of feed into that and how things are going to change, with all those questions presented again? Sorry, I think slightly babbling.
So I think Ethereum is still a system of trustware, which is that it doesn't behave just like software, it doesn't behave just like hardware. It behaves like this new thing that has consensus rules implemented in a network, et cetera, et cetera. I don't want to really get into a discussion of Ethereum Classic versus Ethereum with Vitalik sitting in the second row. Yeah, I mean, I think it would be great if he wants to answer the question after this Q&A session if he feels like doing questions. So I'm not the best person to answer that. I think the other comment you made was Lightning Network is proof of stake. That's something I said in the past. And basically what I'm saying there is that Lightning Network involves doing local validation of the same consensus rules as Bitcoin. Has to be the same consensus rules. But you get to earn fees by committing funds into a channel. That sounds very much like proof of stake to me. I think it represents a tremendous opportunity for users who want to run a Bitcoin full node. If you want to run a Bitcoin full node, it takes quite a lot of commitment in data storage and CPU and RAM and bandwidth. Not many people do that, probably about 5,000 to 15,000 users. You're running one right there. I'm running one as well. Great. How many people here are running a full node? 10. Wow. Go Singapore. It takes a big commitment in resources, and you don't get paid to do this. How many of you would be running a full node if you could also run a Lightning node, commit some Bitcoin to it, and earn fees on it? And so now you see that was about 20 people. So clearly incentives matters. Lightning is one way we can incentivize running full nodes, fully validating nodes, and also full archive nodes potentially. That's going to be a really important development in Bitcoin, and I'm very much in favor. Now, you would think that a group of miners that run nodes that already collect all transactions, right, already have to be fully validating nodes, would look at Lightning Network and go, hey, we could earn more fees using the same infrastructure by running Lightning nodes. We could be hubs for payments. We could extend into this space. Why are they not doing that? Because Lightning Network and running full nodes is software. And it requires maintenance, system administrators, and security professionals, and configuration, and upgrades, and all of the kinds of things that you can't simply get someone to rack and mount hardware to do. It's an alien world. It's not better. It's not worse. It's just on the other side of that culture divide. That goes a long way to explain why miners aren't jumping up and down and saying, hey, yeah, I want to run Lightning. We're going to be best positioned to be running these hubs. Because it's not the same as racking mining hardware. All right, question over there?
Hi, Andreas, Landon here. You mentioned just now during your talk that one of the great things about Bitcoin is that we get distributed trust, right? Neutral trust.
Yes.
And I was just wondering, between private blockchains and public blockchains, how are private blockchains going to be able to capture this?
How do private blockchains create decentralized trust?
Yes.
They don't.
So
it's really simple. They don't. This is the fundamental bug in the center of this whole discussion about private blockchains, is that the reason decentralized public blockchain works is because it allows open, competitive access to anyone for the consensus rules. And that allows it to remain neutral because it creates a degree of censorship resistance and neutrality by the open participation. If you close it to a specific group of named and known and vetted participants, they can no longer be neutral. They are obligated by law to make choices. Those choices may, in fact, have more to do with other aspects of their operation. Maybe, for example, they're doing a settlement function, and they're also market makers in that market. Do I validate transactions by the consensus rules, or undo that transaction that cost me $100 billion in market losses yesterday? Oh, I don't know. Which should I choose? Right? And so the private blockchains fail fundamentally because of that reason. They become less secure over time. They can be coerced legally and in other ways to invalidate and rewind transactions. And they don't offer the characteristics of open public blockchains. Now, that doesn't mean you can't use them to do anything. It just means you can only use them to do a very limited set of things, for which, in many cases, a database is a better solution, a better choice. And so we'll see this battle. We see it already on the internet. Part of this has to do with a fundamental assumption that exists throughout most societies, and that is that something that is guarded and closed is more secure than something that is public and open. The internet has now proven that that is not the case. But not everybody got the message, right? The most secure companies online are the ones that are public, open, and outward-facing. Companies that are inward-facing and closed get hacked from the inside, and no one yet knows how to make them secure. So when it comes to blockchains, the open, public, outward-facing one is the secure one. In trying to make it more secure by applying control, backfires badly. You know, that's not a lesson that you have to teach by explanation or persuasion. Let the market teach that lesson. Let them build it, and let them call it blockchain.
Thank you.
All right, on this side.
Yeah, so right now we know that Bitcoin has like the largest network effect. So in the event of a contentious hard fork, how likely is it that Bitcoin becomes obsolete as the main currency and other currencies take over like by far?
That's a very good question. How likely is it that Bitcoin becomes obsolete? I don't think it will become obsolete. I think if it faces a contentious hard fork, this is an example of things to come. Bitcoin will be attacked. It will be attacked through its mining. It will be attacked through the network. It will be attacked legally. It will be attacked in every possible way. If you don't think Bitcoin's going to be attacked, you've misunderstood what this is about. You don't go and poke a $20 trillion industry and go, hey, we're going to disrupt you. And then wait for it to roll over, right? This is offensive to a lot of governments and a lot of very, very rich institutions. And there are a lot of people who don't want to see Bitcoin succeed because it's decentralized, and they're going to attack every aspect of it. Every aspect of Bitcoin will be attacked. So if a fork happens, we get to learn what happens when a fork attack occurs. And we learn how to defend against fork attacks. Make no mistake, anybody who walks into this thinking that a fork will be unopposed is going to very quickly discover that this will be a battle on all fronts. Day one, we've achieved 51%. We are now going to fork Bitcoin. Kind of seems like, hey, shipping date is here. Our work is done. Your problems are just about to begin, my friend. You launch a 51% attack, that means you are 7 blocks ahead every 24-hour period, if you can sustain it. But inevitably, the two sides are going to attack each other. They're going to attack each other on the network. They're going to attack each other with denial of service attacks. They're going to attack each other with hash rate. They're going to attack each other publicly, privately, anonymously, and not, in every possible way and immediately. Every bug in the software will get poked and then poked again. And if you try to fix it, you'd better write that code well, because if you put another bug in, that's going to get poked too. And then it becomes a battle about who has the best software development team and how quickly they can maintain that code and keep uptime, because that race is only 7 blocks wide. I don't think some of the people who are threatening to do a hard fork at 51% have thought clearly about the implications of what happens immediately afterwards. This is not going to be an easy game. It's going to actually allow Bitcoin to test all the possible attack scenarios on nodes, on networks, on relay networks, on hashing, transaction malleability, replay transactions, and everything else. What will come out of that? Probably a Bitcoin that's worth a lot less. Or, in my view, a technology that's worth a lot more, because it's battle hardened. When it comes out of that, it will have survived its first fork attack. And we will know a lot more about what happens in highly contentious fork environments. Ethereum taught us a lot, but it didn't teach us much about a highly contentious fork. The fork was initiated by the main development team, which had more than 80% of the hash rate on their side. The other thing to remember, and I think this is important, there's a lot of people who say, if Bitcoin stumbles, it's going to be overtaken by one of these other currencies. it's very important to not mistake smooth sailing for good sailors, right? In order to have scaling problems, you first need to have scale. In order to have governance problems, you need to have a controversy to govern over, right? And everything's hunky-dory kumbaya until you have $20 billion on the table, and then the long knives start getting sharpened. Since this is March, we can use a reference, beware the Ides of March, right? And you can then say, oh, it's not what it looked like. It's not what it looked like. You know, don't pay attention to the stabbing. Really, pay attention to the fact that we all came together to stab together. That's the Roman Senate quote. The point here is that what's happening in Bitcoin now isn't unique to Bitcoin. If one of the other currencies gets to this scale and has to handle this many transactions, they have a scaling problem, which they're going to have to resolve. There will be differences of opinion as to how to resolve that. Some approaches will lead to massive centralization and a takeover by miners. Some approaches will lead to failures in architecture and software. These problems will repeat for every other currency. These are the rites of passage. You first have to grow up to face them, right? And so the big advantage that many of the other blockchains and currencies have is they can look at Bitcoin, watch what happens, and learn these mistakes cheaply so that they don't have to repeat them expensively. Now, how many of the blockchains are actually doing that? Not many. Because, for the most part, they're too busy going, we're the best, we're going to win next, right? And not paying attention to the fact that these exact same problems are going to exist in their own blockchains. There are no easy answers. There are lots of very delicate design trade-offs in how you deploy Trustware. And Bitcoin is paving new ground. It's carving a new path. No one has gone here before. Pay attention. We have a lot to learn. This is a fantastic experiment. But it's not easy. It looks easy back there. I like to remind people, who was here when Bitcoin was in 2013? Anyone here who used Bitcoin in 2013? Yes, a few people? OK, how much was the average fee? 0, right? How many blocks were full? 0. How big was the block size problem? 0. How much of a governance problem did we have, or danger of a contentious hard fork? 0. You look back at 2013 and you go, easy days, right? What changed? What changed was, now there's $20 billion at stake, and the game gets serious, right? So it's easy to think that it will always be smooth sailing for the other cryptocurrency because they got everything right. That's not going to be the case.
Hi, I'm more of an observer of the scene. I am not into the programming or mining or anything. But I have a sense that Bitcoin will have a place in the world in the future. Just want to understand from your point of view, what does it take to get there? And maybe even how long? And just to add one more thing would be, how do the different cryptocurrencies come together? Is it like Japanese yen and US dollar? How do we understand the relationship?
Yeah, thank you. Good question. So what it takes is time, and I don't know how long. That depends on what happens next. Bitcoin doesn't exist in a vacuum. It exists at the same time in competition with many other cryptocurrencies and development models, but it also exists, more importantly, in competition with government currencies and regulations and cross-border transactions. And the world is a very strange place right now when it comes to government currencies. There is a massive crisis happening, which has nothing to do with Bitcoin. The currency crisis that is happening right now on the international foreign exchange markets is unprecedented. There has never been a time when more than 20 central banks have pegged their interest rates to 0 and cannot seem to figure out a way out of it, right? There has never been a time when the stimulus going into economies is bigger than it's ever been on a global scale, tens of trillions of dollars over a decade, And the output in growth has been minuscule, less than 2% global GDP. That's never happened before. So this is the environment in which Bitcoin is happening. And Bitcoin is tiny. It's just like a little annoying fly in the background. But what happens in the big space changes what happens to this little thing, right? Bitcoin wasn't that interesting in India until India decided to take its own currency and go, let's see what happens if I do this. Oh, damn it. Now, if a couple more governments do that, that changes how Bitcoin survives. So that's one thing to remember. In terms of the relationship between Bitcoin and the other cryptocurrencies, it is very different from the relationship between national currencies. National currencies exist in a zero-sum game delineated by strict, well-defined borders in which every jurisdiction is contained. Digital currencies are not playing in this game. The cryptocurrencies of our world exist globally. They ignore borders completely. They mostly ignore regulations completely. They can be transferred for each other at any time with almost zero friction, 24 hours a day on international markets with very little risk and cost. They can be traded across borders without being stopped. There's no currency controls, and you are not obligated to use any of them. That's a very different game. So where national currencies play this zero-sum nationalistic game of, for us to win, they must lose, that's not what's happening in cryptocurrencies. And look at the market dynamics. Every few months, Bitcoin does something spectacular, right? Either spectacularly good or sometimes spectacularly bad. The price does one of these, and then people spread for the alts. And you see these massive outflows, because the main way you get into most of the other digital currencies, with probably the exception of Ethereum, is you get through Bitcoin. You usually can't buy the others for most fiats. And so you have these outflows into these other currencies, and then the whole market rebalances. But what's interesting is more currencies from outside come in, and the whole market gets bigger. So every one of these oscillations results in a market cap for all of the cryptocurrencies that is much higher than when we started the oscillation. You come out of it, everybody's winning. So the interesting thing is that all-time highs in coin X does not mean all-time lows in coin Y. In fact, if you look at the charts, we're all doing all-time highs at the same time, right? So it's a very, very different environment than traditional currencies. All right. One more and then we stop. OK. One more and then we stop. Is it a good one?
What's your view on ICOs in general? Do you have your view on ICOs? Initial coin offerings?
Initial coin offerings, yes.
And are there any initial coin offerings you're very interested in, and why?
Great question. So who knows what initial coin offerings are? OK, great, great. I think one day in the distant future, the possibility of being able to fund new initiatives and create ventures on a global basis without the traditional limitations is going to open opportunities for companies that have never had opportunities before. The problem is that, first, investors will have to run the gauntlet and swim in these shark-infested waters full of these unscrupulous people who are taking their shitcoin and making an initial offering, whose primary purpose is not to add funding for a worthwhile project that is already achieving success, etc. It's not to generate value or take growth to a next level for something that is already worthwhile. They smell money in the water, and they come like sharks. I would say at least 95% of the ICOs out there have no basis, fundamentals, or anything like that. Now, does that mean that we should have a regulatory agency that says, that's a good one, that's a crap one? No, we've tried that. They said that's a good one about Madoff's Ponzi, right? That doesn't work either. But it will require much more maturity among investors to learn how to identify things that are Ponzi's. One great way you get that education is by losing your money, right? And eventually, we're going to have a bit of a clear out in this space. Part of the business cycle is every now and then, you have what is hopefully a minor forest fire, and it clears out all of the brush and dead leaves at the bottom of the forest and doesn't kill too many of the trees, and it makes the system much more healthy. We haven't had that in the stock markets in 8 years, and it's beginning to show. And it's going to be very bad when it happens because the market forces have not allowed it to happen by doing stimulus. I expect we're going to have a great washout in ICOs too, when investment is going to dry up. Maybe it will take dropping the valuations of some of the coins that are feeding into these ICOs. That will be a good thing. A bunch of investors will lose their money. They'll learn a lesson. The next round of investors will go into this with much more conservative attitudes. And then 4 or 5 years later, they'll completely forget the lesson and have to learn it all over again. That's the way it works. It's the way it works in markets. Look at the S&P 500 right now. It's as if recessions never happen. It's never going to happen again. There are traders in the S&P 500, 30-year-old people, who have never traded in an interest rate environment above 1% in their lives as traders. Imagine that for a moment. So the spigots have been fully open the entire lifetime of their trading. And that's now the majority of traders. They're about to have a rude awakening. In ICOs right now, you've got Bitcoin and Ethereum that are generating tremendous gains for people who have invested early. And they're taking those gains and they're like, where do I invest this money? And that's feeding into both blockchains that really shouldn't be funded and cryptocurrencies that really shouldn't be funded, that have nothing to offer, and a lot of scammy ICOs. I'm not going to say they're all scammy. I'm sure there are some that are very interesting. I'm sure if I named them, I'm going to get a lot of flack for not naming your favorite one, and if one of them turns out to be a scam, it was all my fault. So I'm not going to name any of them. But what I'm going to say is, you have to be careful. A lot of these ICOs are promising great riches. And the one thing you can be sure of is someone's promising you get great riches. They're talking about themselves, right? Like, this ICO is going to make all of us, and by all of us I mean mostly me, rich. Don't believe it. If one of these things has a viable product to offer, then write more of that code and less of the ICO code until you actually need funds for organic growth. How about build it first and they will come, rather than fund it first and we'll build it later? So I am very, very skeptical. In general, don't look at this as a space for investment. This is not a space for investment. This is a technology. It is an unstable, volatile technology with a lot of drama, right? And a lot of volatility. I don't invest in these things as an investment. I use these currencies as a technology. I use them as a currency. And if I get paid, and I get paid in Bitcoin and it's $20, and I get paid in Bitcoin and its exchange rate is $2,000, it makes no difference to me, right? I might lose some of my savings, but that's not why I'm in this space. So be very, very careful. Learn. Don't trade. Learn. Thank you. Thanks so much.